Alright everyone, so today we will be doing the 7th chapter of O level in IGCSE Computer Science, which is algorithm design and problem solving. So this is actually one of the most important topics of P2, so make sure that you listen very carefully, and if you have any problems, make sure to reach out to me. Alright, so coming down to the first topic, which is the program development life cycle. Alright, so there are basically 4 different stages: the analysis stage, the design stage, the coding stage, and the testing stage. Alright, so the first stage is basically consisting of 2 major tasks, which are abstraction and decomposition. Alright, so abstraction is basically just when you simplify the problem and you're removing all of the unnecessary things, right? Secondly, decomposition, as the name suggests, is basically when you are breaking down a complex problem into smaller parts. All right, so there are basically just 4 different types of categories into which that problem is basically divided into. All right, inputs, processes, outputs, and storage. All right, so these are basically the 4 parts into which a problem is divided. Coming down to the design stage, right, this stage is basically just comprised of the planning, the solution, and the structure of the software. All right, so we will basically draw all the flowcharts, write all the pseudocode and structure diagrams in this part. All right, so we will actually study what flowcharts, pseudocode, and structure diagrams are later on. All right, so this is basically the stage in which these 3 things are used. Then we will actually code this stuff. All right, so the program or the application that we have to make, this is the stage in which we will actually code the thing that we designed in the previous stage. Lastly, testing. All right, so one of the most important stages during development of a program is the testing stage. All right, so this is basically when you are testing the program to find errors and to actually see if it is working according to the client's demands and how the client actually wants the application to work. So this is basically the stage in which you use 4 different kinds of testing data. All right, so make sure that you remember these 4 different kinds of data. So the first type of testing data is normal data, right? This is all the data that is within range, right? Secondly, we have extreme data. All right, this is which is at the extremes of the given range. And then we have boundary data, right? This is basically all the data that is on the limits of the boundaries, right, or the limits of the range of the data. And lastly, we have abnormal data, which is outside of the range. So this is basically just the 4 different stages that an application or a program goes through when it is being developed by a software firm. All right, so coming down to computer systems and subsystems. All right, so a computer system is basically a complete working system that consists of multiple subsystems. All right, so computer system is basically one big system which consists of multiple subsystems. So subsystem is basically the distinct functional parts of a computer system that work together to perform specific tasks. All right, so for example, the first subsystem can be the CPU. All right, we actually studied about the CPU before. Another example of a subsystem can be the memory subsystem, which actually includes the RAM, ROM, the HDD, SSD, all of these kinds of things. And then we have the input-output subsystem, right? This can include all the input-output devices, all right? And these systems can obviously also be divided into further systems, right? So for example, if you have the input-output system, right, a keyboard can have its own separate subsystem, the mouse can have its own separate subsystem, so on and so forth. All right, so a computer system is basically just a system that is consisting of multiple subsystems. So coming down to the first major design thing that we use, right, which is called structure diagrams. So structure diagrams are basically just visual representations of the hierarchical structure system, right? So over here you can see that I have given an example of when we are developing an Islamic app. All right, so let's just suppose that if we are developing an Islamic app, all right, we will need to divide it into multiple parts, right? So over here you can see that inside that Islamic app, maybe the client has demanded that he needs 2 different things, right? Prayer times and Quran reader. All right, so let's just suppose that the client wants there only to be 2 things inside the Islamic app, right? So first we will just break down the whole Islamic app into 2 different parts: prayer times and Quran reader. Next, we will divide that part into further multiple parts. All right, so prayer times can be broken down into other parts, such as prayer times throughout the year, and different prayer times in different places. And then the Quran reader can be divided into multiple parts. For example, it can have a PDF viewer, it can have bookmarks, it can have recitations of other reciters, all of that kind of stuff. So we will actually study a few examples of structure diagrams later on when we are studying past papers. All right, so coming down to flowcharts. So flowcharts are basically just diagrammatic representations of a process or an algorithm. All right, so over here you can see that I've given an example of a flowchart, right? So you can see that we will be given an algorithm, all right, and we will have to convert this algorithm into a flowchart, right? So this is basically just using symbols like this, and it uses arrows and text to basically turn that algorithm into an easier form to understand. All right, so let's study the first few symbols. So first of all, we have the start and end symbols. All right, these are basically just used to show the reader what the start and the end of the algorithm is. And then we have the symbols for processes and actions. All right, so you need to remember that this rectangle and this are two different things. All right, so this rectangle that has two sides are basically used whenever we have a function, right? So whenever we have a procedure or a function that is being used as a process, that will always have two sides. All right, however, you can see over here that a simple function of just assigning the value of 0 to a is being performed, right? Therefore this will not have double sides. All right, so coming down to the input and output symbols, so these are obviously only used when you have to input something or output something, right? These are rhombuses. So whenever we want to input something, we will just write input x, and it will store that value that it takes from the user into the variable x. All right, but if you want to output something, we can even write just what you want to output, or if you want to output what was stored in x, you can just write output x, and it will output whatever was stored in x. And then lastly, we have another symbol, which is the decision symbol. All right, this is basically just an if condition. All right, so it just asks a certain type of question, right? So over here you can see that if x is less than 0, it will perform the task that is over here, and if it is not less than 0, it will perform the action that is over here. All right, so these are basically just the few symbols that are used inside flowcharts. All right, so let's just study the first algorithm. All right, so over here you can see that I've written a small algorithm, right? First we have to start this algorithm, then we have to input the first number and the second number, then we have to compare them, and once we've compared them, the comparison is basically just if a is greater than b or not. All right, so if a is greater than b, right, it will be the maximum. If b is greater than a, it will obviously be the maximum. All right, and then that will basically be stored in a separate variable, and then that variable will be output. All right, so over here you can see that we have the start of the start of the algorithm, then we input the two variables a and b, right, and then we compare them using the decision symbol. All right, so we basically compare if a is greater than b, right? If a is greater than b, we will output a, right? And if b is obviously greater than a, it will output b. All right, so this is basically just a small example of how a flow chart is representing an algorithm. All right, so coming down to pseudocode. So this is actually one of the more difficult parts, so be very attentive when you're listening to this. All right, so pseudocode is basically just when you express or write an algorithm in a certain type of language. All right, so this is a very natural language. It is not like a high level language like Python or Java, but it has a very strict type of format. All right, and this basically makes sure that all types of programmers can understand pseudocode, right? So let's just study the first method that is used inside pseudocode, which is assignment and variables. All right, so variables are basically just names which are given different values. All right, so over here you can see that using this arrow, right, we are basically assigning the value of 80 to price. All right, so price is basically, you can say, a container that stores the value 80. All right, so whenever I want to maybe print out the value or output the value of price, right, it will actually be outputting 80. All right, it will not actually output the it will not actually output the text price, rather it will actually output the value 80, because inside price it is actually just storing the value 80. All right, so this is how you make an assignment, right? This is basically what we mean when we are assigning a value to a variable. All right, so over here you can see that we can actually use variables to perform calculations as well, right? So obviously we cannot multiply text by numbers, right? It is actually performing the multiplication of the value 80 by 0.9. All right, and these are the different types of signs that can be used in pseudocode, right? Plus, minus for obviously subtraction and addition, and then we have this forward slash for division, and then we have this star for raised to the power, and then we have round brackets for prioritizing and grouping. All right, so coming down to input and output. So over here you can see that I've written down input in block letters, and then I've written down name, right? So this basically means that we will take an input from the user and we'll store the value inside the variable name. All right, so let's just suppose that I'm taking an input from the user, and the user gives the input Note Academy. All right, so that will basically be assigned to the variable name. All right, that this value will basically be stored inside the variable name. All right, and when we want to use it later on, you can see here that if I want to output it, I will just write my name is, and then if I want to combine this phrase with name, I will use a comma, right? So over here you can see that I've used a comma to combine different things, right? So over here I've combined a string with a variable name. All right, so this will basically output my name is Note Academy. All right, so this is how you input and output stuff in pseudocode. So coming down to if else statements, so this is a very interesting type of statement. So this is basically just representing a simple statement of pass and fail, right? So if we are giving the program an input of marks, right? So we are just writing down the marks of separate students on the computer. This will basically just compare those marks with the given criteria, right? So over here you can see that marks will be compared with 49, right? So if those marks are greater than 49, it will output pass, and if they are less than 49, they will output fail. All right, so that is basically just a small example of an if else statement. All right, so also make sure that you're very particular about the format, right? So over here you can see that if, then, else, and end if are all written in block letters, right? Same as output, right? And over here you can see that input was also written in block letters, right? Capital letters. So make sure that whenever you want to write if else statement, right, you write it down in capital letters, right? And also make sure that whenever you're writing down any kind of statement, right, for example, even if you have a loop that we'll study later on, they always have an end statement, right? So over here I started an if statement, it has an end if at the end of it. All right, and that is also in block letters, and it does not have a space in between, right? And then over here you can see that I've written down then, and then I've written down else in a separate line. All right, so when I wrote down the first if statement, I gave an indentation, right? So you can see that they're not in the same line as if, right? They are actually indented, and then when I want to write down the condition, I indent it again, right? So you can see that else is in a separate line, and then output is in a separate line, right? So always remember that when you want to write down the statement, you are indenting them, and you're also writing the statements in block letters, and the rest of the stuff in other types of maybe lowercase or uppercase, that does not matter. But make sure that whenever you're writing down the if statements, you are writing down in capital letters. All right, so we also have a thing that is called nested if statement, right? So this is when you are writing an if statement inside an if statement. All right, so over here you can see that I've given an example of a nested if statement. All right, so over here you can see that the first condition is the same as before. All right, so if marks is greater than 49, then, right? However, rather than writing down output pass, I've just given it another criteria using another if statement, right? So over here you can see that I've given it another condition, that if the marks are greater than 74, you will output grade is equal to A, else you will output grade is equal to B, right? And if the first statement was true, right, only then this statement will run, right? It will ignore this else statement, right? It will not even go through this. However, if this first statement was not true, right, it will ignore all of this and it will go straight to these statements. All right, so over here you can see that it will only output grade is equal to F, right? It will not even go in this statement. So this is also an example of a nested if statement. Coming down to case of statements, so this is actually when you have a lot of if statements. So rather than making them using nested ifs, this will become very lengthy. Instead of that, we just use case of statements. All right, so over here you can see that marks are basically being given multiple scenarios, and using these scenarios we output or perform certain tasks, right? So for example, over here you can see that marks are basically compared first of all with less than 50, right? If it is less than 50, it will output grade is equal to F, and then the condition will finish, right? If this statement is not true, it will move on to the next statement, right? Then it will see that if it is less than 60, right, and if it is less than 60, it will output grade is equal to D, right? If this statement is not true, it moves on to less than 60, less than 80, right? And if any of these statements are not true, right, if any of these conditions are not met, it will output this statement, right? So anything that is written in otherwise, right, it will do that specific task, right? So in this scenario, we will output grade is equal to A, right? So always remember that when these conditions are not met, anything that is written ahead of otherwise, that specific function will be performed. All right, so over here you can see that case also has an end case at the end, and otherwise is also written in capital letters. So make sure that you are very specific about the format and you remember this when you're practicing it. This will actually become very easy to remember. However, inside exams you have a lot of pressure, so you forget these kinds of things. So make sure that you practice them and remember them when you're attempting it in your exams. All right, so another thing, you can see that I have used colons over here, right? Also remember these. So coming down to a simple for loop. All right, so a for loop is basically a count control loop. All right, so we will actually study these types of loops later on in the programming chapter, right, which is chapter 8, which is coming up. So a for loop is basically just used to perform a specific task certain number of times, right? So over here you can see that we have a variable, right, and then we have an assignment of 1 to 10, and then we are performing a specific task. All right, so this basically means that x will be given the assignment of 1, right, and then it will perform a specific task, and then it will go to the next value of x, right? So when we are writing down 1 to 10, this basically means that we will go through all of the values 1 2 3 4 5 6 7 8 9 and 10, right? So this will basically result in this function or this action being performed 10 different times. All right, so this is how you perform something 10 different times using, or a certain number of times using a for loop, right? So if I wrote down maybe 20 over here rather than 10, this action will be performed 20 times. All right, so moving on to repeat until loop. So repeat until loop is basically a post condition loop, right? So this basically means that the actions in this loop will take place at least once. All right, so there's another type of loop which is a precondition loop, right? So over here this is a while loop, which is a precondition loop. This will basically only run if the condition is true, right? So these actions will not take place unless the condition is true. However, in this repeat until loop, this basically is a post condition loop. Therefore this will always run one time, right, and then it will compare it with the condition. All right, so it will always run once. So anyways, you can see that I have written down a simple example of a repeat statement, repeat until loop. All right, So over here you can see that we have a count variable, right, which is actually just incrementing. We will actually study this later on, but I will still explain it to you right now. So what is actually happening here is that it is taking the previous value of count, right, it is adding 1 to it, and then it is storing it into count again. All right, so before, you can see that before we actually start this loop, we had a count assignment of 0, right? So the variable count is being assigned to the value of 0, right? So over here you can see that 0 plus 1 will basically mean that this will be storing 1 in here. All right, and then in the next time that this loop is run, we will have 1 in count, right? So 1 plus 1 will basically mean that the new value of count will be 2. Right, so this is how you increment or add 1 to a certain value. All right, so I can actually explain, we can actually replace 1 with 2 or 3 or 4, whatever you want to replace it with, and then we check the condition until count is equal to 10. Right, so this specific loop is also going to run 10 different times, right? So the first time, when the counts value is actually 0, right, it will do 0 plus 1, then it will store 1, and then it will go through all of these statements again, and then it will actually compare the value of count with 10, right? So over here the condition is actually that this loop should run until count is equal to 10, right? So it will compare the value of the current value of count with 10, and the first time that it runs, its value is actually just going to be 1. Therefore this loop will repeat again. All right, and keep on doing this until count is 10, and then it will just simply output total. All right, so coming down to this precondition loop, which is basically a while loop, right? So over here you can see that when we input age, right, it will compare age beforehand, right? So this will only run if the condition is being met. All right, so in this statement, the repeat and loop, you can see that this loop will always run once, and then it will compare it with the condition. However, over here the condition will always have to be met before you can actually enter the loop. All right, so it will compare this variable age with 17. It will see if the age that was input by the user is actually less than 17 or it is greater than 100. All right, so this is basically a mechanism that will ensure that the age that a person is entering is between 17 and 100. All right, so let's just suppose that you are entering your age on a website, right, and you input the age 1246, right? That is actually not even possible. You're just having a little bit of fun, right? So this loop will be used in those kinds of scenarios, right? It will take that age and it will compare it with these conditions, right? So if that age is less than 17 or is greater than 100, it will enter that loop, right? So our age that we put over here, right, so let's suppose that we entered the age of 1024, right? That age will obviously be greater than 100, therefore it will enter the loop, right? So then it will output this statement, enter a valid age, and then we will have to input age again, right? So let's just suppose that we don't actually input the correct age, right? We just write something else again, right? Let's just suppose that we write negative 200, right? So we input another type of wrong age again, right? It will start the loop again, right? So this is basically what an end while loop is, right? It will keep on running until we actually meet that condition. All right, so when we enter the valid age of, let's just say 20, all right, it will compare, let's just say that we are saying 20, all right, so it will compare that age with these conditions. All right, so that is less than that is greater than 17 and less than 100, therefore it will actually not run, all right, because none of these conditions are being met. All right, so that age that we have entered is not less than 17 and it is not greater than 100, therefore this while loop will break. We will break out of this while loop and we will not enter this while loop again. All right, moving on to standard methods of solution. So these are basically just a few functions, or you can say statements, that are used in a certain way so that we can perform certain tasks. All right, so one of them is actually counting. All right, so you can see here that I actually explained this before as well. I'll just explain it to you again. If you want to count how many times something happens, right, you can use a count variable and you can increment it every single time something happens. Alright, so over here I've just given you a simple example of, when we are going through a list, right? And we want to check how many times Note Academy is included inside that list, right? So let's just suppose that we have a list that has Note Academy, then it has something else over here that has Note Academy again, something else, all right? So in this list, we will have two Note Academies, all right? So you can see here that I use a simple for loop with a function of length, right? So this length function is basically just going through the whole list, right? It will basically just calculate the list of the length and then it will put that over here, right? So basically, let's just suppose that list over here is basically 5, right? So instead of length, it is basically just 5, all right? So it is basically just writing down 5 instead of length list, all right? So this means that this for loop will basically run 5 times. Alright, and then you can see that we are performing a comparison over here, right? So every single time that we have a certain item inside that list, it will be compared with the variable Note Academy. Alright, it will be compared with the string Note Academy, right? And if that condition is true, right? So if that variable inside the list is the same as the string Note Academy, it will increment count, right? So for example, let's suppose that we are going through the first list, all right? Let's suppose that we are going through this list, all right? So first of all, we see that the count will be given the value of 0, right? And then we will enter this loop because this will have to run 5 times no matter what, all right? So first of all, I will have the value of 1, all right? So you can see here that it will start from 1 and it will go to 5, all right? So list will basically have 1. So this basically means that the first index of list, right? So a list is basically numbered, right? So 1 2 3 4 5, right? So in normal programming scenarios, a list is basically numbered from maybe 0 till 10 or 1 till 5, anything like this, right? So it is basically just numbered. All of the items inside a list are numbered, right? So in this scenario, let's suppose that our list starts from 0, starts from 1 and goes on until 5, right? So over here we can see that the first index of this list actually does contain Note Academy, all right? So that Note Academy will be compared with this string, which is the same as Note Academy, right? This means that this if condition over here will be true, right? This condition is true, therefore it will add 1 to count, right? So the current value of count is actually 0, therefore it will add 1 to it, and this count will actually be 1, right? And then next time it goes through the second loop, right? It sees that it is not exactly Note Academy, therefore it will not enter this if statement and count will not be incremented, right? We will not add 1 in count. Then when it goes to the third index, it will see that it has Note Academy again, right? Then count will be incremented again, right? Then we will have count as 2, all right? So count will be given the value of 2. Next it goes through the fourth index, right? This does not have Note Academy. Then you go to the fifth one, it does not have Note Academy, and then it will just end, right? So we will have the value of count is equal to 2, which is basically showing us how many times something happened, all right? Coming down to finding the maximum and minimum and average values. So this is actually very easy, all right? So first of all, you can see that in order to find the maximum and the minimum of something, you will need to use a for loop, all right? So if we are comparing something inside a list, right? Let's just suppose that we have a list that is 2, 8, 10 and 4, all right? So let's just suppose that we have this simple list. So what we basically want to do is we want to find the maximum, the minimum and the average of this list, right? So first of all, we will have a for loop that is the same as the length of this list, right? So I explained this to you before. Secondly, what we will do is basically we will just be comparing the current value of the list with the maximum value, all right? So we will have a maximum value of the list, all right? And then we'll keep on comparing it with the first value, all right? So let me just tell you what this means, all right? So over here you can see that we are comparing each variable of list with maximum. So let's suppose that we have 0 over here, right? We can have the first value of list as well, anything. All right. So first of all, what it does is it basically goes through all of these variables and compares it with the maximum value. All right. So when something is greater than the value of the first maximum, right? So for example, if you're going through this list, right? So 2, 8, 10, and 4, it will have the value 2 in the beginning. All right. So let's just write that down. 2 over here, and then minimum will also have 2 over here, right? So let's just save that for later. So first of all, what it will do, it will compare the first value, right? Because I will have 1 in the beginning, right? It will have 1 in the first time, right? So therefore it will compare the first index value. So 2 will be compared with 2, and if that condition is met, that will not be doing anything, right? Because 2 is not greater than 2, right? Then it will go through the loop again. All right, so I'll just ignore minimum and maximum for now, right? I'll just ignore minimum and average for now. I'll just go through this loop so that you can understand the concept of maximum. All right, then it goes to the second one. All right, so now we have 8 in the second index. All right, so it will compare 8 with maximum, right? So in the first round we see that we stored the value of 2 in maximum, right? So 8 is obviously greater than 2, right? This will be true. Therefore maximum will be given the current value of the index. All right, so 8 will be stored inside maximum. All right, then we do it for the third time, and then over here you can see that we have 10 over here, right? Then 10 will be compared with the value of maximum, right? So now we actually stored 8 over here, right? So 2 was actually cancelled out, and now we have 8 over here, right? 8 will be cancelled out because 10 is obviously greater than 8, right? This will be true. Therefore we now have a new maximum value of 10. All right, and then it will compare it with the fourth index, which is actually just 4, and 4 is not greater than 10. Therefore the maximum value will remain the same, and we'll get the maximum value of 10. All right, this is just an example of maximum, and the same happens with minimum, but just in a different way. It will just keep on comparing it until the loop is finished. All right, and it'll actually just compare it with lesser than sign. All right, over here you can see that if this is actually just using a greater than sign, we will use a lesser than sign over here. All right, so in order to do minimum maximum, this is what you have to do. So in order to find the average, all you have to do is basically just total or sum all the values inside that list and divide with the number of items inside that list. All right, so over here you can see that every time we are going through this loop, we are adding the current value of the list index and we are adding it to total, right? So when we over here you can see that we started with 0, right? We initialize the value of total to 0, and then for example the first time total will have the value of 0 and the current index of that list will be 2, right? So 2 will be added to 0, therefore the value of total will be 2. And then second time we will have 8 over here, right? So 8 plus 2 will result in 10, and then we'll have 10 over here, so 10 plus 7 20, and then we will have 24 in the when the whole loop is basically finished, right? So 20 will be divided by the length of the list, and the length of the list is basically just going to be 4. Therefore 24 divided by 4 will be 6. All right, so the average will be 6. So this is how you find minimum, maximum, and average. Coming down to totaling. So totaling is actually, I just explained it to you before as well. All you have to do is basically just take a variable and keep on adding the value of the current index of that list to the total variable. Alright, so the bubble sort is basically just a simple sorting algorithm. Alright, it can sort a list into ascending or descending order. Alright, so that will basically depend on this particular sign inside the pseudocode that I'll explain a little bit later on. Alright, so make sure that you listen very carefully because this is a concept that students mostly struggle with. So yeah, just make sure that you listen carefully. Alright, so I have an example down below as well. So even if you cannot completely grasp this concept through the pseudocode, I'll still explain it to you in the example. All right, so just listen carefully. So first of all, we have a few variables that we need to look at. All right, so in this particular example of pseudocode, we are using a list that is of length 10. All right, so the length of the list is actually 10. However, in boundary we will actually put 9 instead of 10. All right, I'll explain it to you why a little bit later on. Secondly, we will use a repeat until loop. All right, you can see here that we are using a repeat until loop. All right, so this loop will keep on repeating until no swap has occurred. All right, swap basically means that we are replacing the first index with the second index, or maybe the previous index with the next index throughout the whole list, or until boundary is 1, right? So when boundary is 1, this basically means that we have gone through the whole list multiple times. All right, so this loop will keep running until no swap has occurred or the boundary is 0. All right, secondly, we have another variable that is called swap. All right, so swap is basically a boolean variable. All right, boolean basically means that any variable that has true or false or 1 or 0, that only has basically two outcomes, that is a boolean variable. So over here we will basically set swap as false. All right, and also you can see that all of this is inside the repeat until loop. Secondly, we will have to go through the for loop. All right, so the for loop is basically going through all of the indices from 1 till boundary. All right, so in the first loop we will actually go through 1 to 9. All right, then we will actually reduce the value of boundary by 1. Then in the next pass it will go through 1 to 8, and then 1 to 7 in the third pass, so on and so forth. All right, so what is actually happening inside this for loop is that we are just comparing if the first index is greater than the second index. All right, so not just the first index, like throughout the whole list, the previous index with the, we are comparing the previous index with the next index. All right, so over here you can see that I've used a greater than sign. All right, so if the first index is greater than the second index, we will swap this. All right, so in order to swap something, we need to introduce a third variable which is called temp. All right, we can use any other name, however, just for convenience, so that we actually know what we're doing, we use temp. All right, so in order to make a swap, you will actually have to first store the value of the previous index inside temp, and then in the previous index you will write down the value of the next index, and then inside the next index you will write down the value of temp, which is basically the first index value, right? So once you've done that, you will turn swap to true rather than false, because initially it was false, and because the swap has occurred, we will turn it into true. All right, so it basically does this multiple times, right? So in the first pass it does it basically 1 to 9, therefore 9 times. All right, so another thing that you need to note over here is that initially we wrote down boundary is equal to 9, right? So boundary was given the value of 9 even though the length of the list was 10, right? So this is done because inside this loop over here you can see that first of all we are comparing the previous index, which is just I, and then we are writing down I plus 1, right? So I plus 1 basically mean 10, right? This means that the last index is also being compared, right? However, if we wrote down, let's say suppose 10 instead of 9, right? Let's say suppose that we wrote down 10 over here, right? 10 plus 1 will basically give us 11, right? And that would result in an error because there is no 11th index inside the list. All right, so make sure that you are very careful inside these exams, because examiners usually like to mess around with these small types of things so that the student finds it a little bit challenging. All right, so make sure that you remember this concept. All right, so coming down to the example, so first of all you need to look at the first pass. All right, so the first pass is basically when the repeat until loop runs one time. All right, the first time. So what we are actually doing is that we are comparing the first index with the second index. All right, so let me just change the color. All right, so we're comparing the first index with the second index. All right, so 5 is obviously greater than 1, therefore we perform the swap, right? And then 5 will be compared with 4, obviously that is still greater, therefore we will make the swap, and then 5 is still greater than 2, we will make the swap. However, in the last one we will compare 5 with 8, right? This will mean that no swap will occur because 8 is already greater than 5. All right, then in the second pass we will compare the first variable with the second one again, and then we'll compare the second one with the third one again. However, you need to know here that inside this variable, right, 4 and 5, these will obviously not be swapped. Why? Because 5 is already greater than 4. All right, another thing that you need to note here is that over here we did 1 2 3 4 different swaps. All right, we basically went through the for loop 4 different times. All right, however in this one we actually go only 3 different times. Right, why? Because over here you can see that we are reducing boundary by 1 every single time. Right, so after each pass the value boundary is being reduced by 1. So over here you can see that the for loop is actually running from 1 till boundary. Right, so this is basically a little bit more efficient method of bubble sort. Right, this basically makes sure that once we've actually sorted the last one, we don't need to do that again. All right, because you can see that 5 and 8 are already sorted. We don't need to compare that again. So this is basically just to increase the efficiency of this bubble sort algorithm. All right, so over here you can see that the for loop will only run 3 times, whereas the first time it was running 4 different times. And then in the third pass we will see that we only perform 2 different comparisons. Right, and these will already not be these are already sorted, therefore no swap will occur. Right, however you need to know here that only 2 different comparisons are being performed rather than 3 like in the second pass. Right, and there are only 3 being performed in the second pass rather than 4 because we were reducing boundary by 1. So this is basically how you perform a bubble sort algorithm. If you still cannot understand this, we will actually go through some of these examples inside past papers as well. And if you still cannot understand them, just reach out to me and hopefully I'll be able to help you out. Alright, so linear search is basically just, as the name suggests, a way to search an item inside a list. Alright, so this example is basically for finding a name inside a list that is of multiple names. Alright, so I'll just write something down over here. So let's just suppose that we have ABC, and then we have CBA, then we have BCC, and then we have ACC. Alright, so this is a random list that I came up with just right now so that we can actually perform this linear search. All right, so 1 2 3 4, I'll just make sure that I write down the indices as well. And let's just suppose that the thing that we have to find is BCC. All right, so this is what we have to find. All right, so first of all, this linear search will output this line enter name to find, and then we input the name. All right, so this is basically just for the user. So I will just input BCC. All right, and it will find that specific value for me, and if it does not exist, it will output that it was not in the list. All right, so we are using 2 different variables over here. The first one is found and then it is count. All right, so found is basically a boolean variable that will basically indicate if we have actually found the item or not, and then count is to make sure that we're going through the list a set number of times rather than for an infinite number of times. All right, so over here you can see that we are actually using a repeat until loop. Right, we're using a repeat until loop. It will repeat until the object, the item that we're trying to find is actually found, or if count is greater than class size. Right, so let's just suppose that in our case the class size is basically 4. Right, the size of the list is actually just 4. If count will be greater than 4, this will mean that we have gone through the whole list and the object was not found. Right, the item was not found, therefore it will give the output that this item was not found. However, if found was true, this will mean that we will be able to output that this the item was found. All right, so let's suppose that we are going through this the first time. All right, so the first value that we give to count is 1 because our list starts from the first index. All right, so first of all it will compare name that we input over here. All right, so we input BCC over here. Right, so BCC will be compared with the first index. All right, so this whole list is basically just student name. All right, so this whole list is basically just a student name, and the count is basically counter. All right, so this is just a little bit of a mistake, so yeah, you can just ignore this. So over here you can see that count was given the value 1. So in the first index we have ABC. All right, so obviously this is not true, therefore if it is not true it will just increase the count. All right, so it will increment count. However, you can see that neither found is true or counter is not actually greater than class size, therefore this loop will not break. All right, we will keep doing this. So in the second pass you will see that name, which is BCC, is compared with the second one. All right, so over here we actually incremented count, so now we will go through the second one. All right, in the second one it was not found, then we'll go through it the third time. All right, and in the third time we will see that BCC is equal to the third index of this list, right? And since it is equal to the third index of this array, it will turn found into true, right? So over here we actually put found is equal to false. Now it will turn found to true. All right, and over here you can see that found will basically be true, therefore this will break out of the loop. All right, then once we actually broken out of the loop, we will see that if found, all right, so found is basically true. All right, so if any condition is true, it will go through this one. All right, so whatever is written after, then this will go after this one. All right, this specific action will be performed. All right, so because found is true in our case, it will output the name, right? So BCC found at position and then counter, which is actually 3 in our case. All right, so this is basically how you perform a simple linear search. All right, so coming down to validation and verification, so this is also a very interesting topic, so listen up very carefully. So first of all, validation checks and verification checks are two different things. All right, validation is basically when you are ensuring that the data entered in your system is correct, sensible and useful. All right, however, verification is when we have to ensure that the data entered into the system is accurate and correctly represents the intended information. All right, so verification is just to make sure that the data that we're entering is the same as what we wanted to enter. However, validation makes sure that the data that we're entering is correct, sensible and useful, right? So let's just suppose that we have a name column in which we're writing down the names of multiple employees. We cannot actually write down a number over there, right? We have to make sure that we are writing down letters. All right, so that is basically what is meant by validation. So let's check the first one, which is range check. All right, so the range check is basically ensuring that the input data falls within a specified range. All right, so let's just suppose that if you have a column that is writing down the months inside a calendar, right, obviously the number that is entered must be between 1 and 12. All right, so this is a little example of how a range check can be performed, right? You just need to have a simple if statement that is checking if the score is less than 0 or greater than 100. Obviously that will mean that we have an error. All right, we want the score, if you want the score to be 0 to 100, all right, you will perform this if statement, if condition. All right, and this will make sure that we perform a range check. Secondly, we have a length check. All right, this makes sure that the input data has a correct number of characters. All right, so if you have an ID card, you will see that all ID cards throughout the whole nation have the same number of numbers, right? They have same length. So this is basically a way to make sure that when you're entering an ID card in a website, it is of a specific length. All right, so this is just a small example of how you can perform a length check. All right, so you can just use the length function to check the length and you can compare it with a specific value. All right, so coming down to type check, as the name suggests, the type check is just to make sure that data is of the correct type, right? So for example, if you're entering someone's age, it must be in integers and not letters, obviously. All right, so next we have a presence check. So this check is just making sure that a field is not left blank. All right, so this is a simple way to check if the field is not left blank, right? So when you input an email address, if the email address is empty, right, this represents an empty string, it will output that this specific field is required or any other statement that you want to output until that email address is not empty, right? So this is a sign of not equal to. So format check basically ensures that the input data matches a specific pattern or format. For example, an email address must have an @ inside of it. All right, and then we have another example of check digit, which has already been discussed in chapter 2. All right, so coming down to verification checks. So there are two basic types of verification checks: visual checks and double entry checks. All right, so visual check is basically just to manually check all the entered data against the original source, right? So if you have a paper on which you have to enter onto a spreadsheet on your laptop, you will just look at the paper and the spreadsheet that you've created and you will manually check if the data is the same as you wanted to enter. And then double entry check basically is when you enter the data twice. Alright, so you're making two different spreadsheets on a laptop and entering them twice and then comparing them to actually check if the data is the same or not. Alright, so now we have another thing that is called trace tables. Alright, so trace tables are basically just a method that is used to manually track the execution of an algorithm step by step. Alright, this is called a dry run. Alright, so over here you can see that we've been given a simple flow chart, right? So we have been given an algorithm in the form of a flow chart, and we have to solve this inside of this trace table. Alright, so these gray boxes, these will already be given to you before, and you have to write down all of this by yourself. Alright, this may look a little bit difficult, however, believe me, this is actually one of the very easy questions inside the exam if you actually put in the practice. Alright, so let's just solve this algorithm. So first of all, we begin from start, right, and then we follow the first arrow. This basically is saying that we have to write down the value of f as 0 and then c as 1. Alright, so this is what we are doing in the first step, right? This is basically the first step. So we are writing down 0 inside the f column and we write down 1 inside c's column. Then we move on to the comparison. Alright, so it is basically asking us to perform this comparison, which is saying that xc should be less than c plus 1. Alright, so c is basically 1, right? So 10 should be less than 1. Alright, because this is not true, we will actually go to no, right? Because this is not true, therefore over here we will perform a swap. Right, so this is basically just a bubble sort being performed. Alright, just so you know, this is a bubble sort being performed in the form of a flow chart. Alright, so over here you can see that we use t, which is basically the temp variable inside the bubble sort algorithm, and then we give it the value of xc, and then xc is given the value of xc plus 1, which is basically x2. Alright, and then we put the value of t inside xc plus 1. Alright, so we are just performing a swap. So over here you can see that first of all we put the value of xc inside t, right, and then in the second one we put the value xc c plus 1, right? So over here you can see that inside xc, which is actually this one, we're putting the value of xc2, which was initially 1, right? So this value move over here and then this value moves over here, right? Then we put the value of 1 inside f, right, which is what we do over here, and then following this arrow you will see that we do c plus 1, therefore we will put 2 over here. Alright, and then we move on to the next line. So we basically keep on doing this until we get to stop. So this is how you basically solve a simple trace table. Alright, so coming down to tips on solving and amending algorithms. Alright, so this is basically something that is best explained using past papers. Alright, so when I actually do past papers, I will make sure that I explain this to you in a little bit more detail. However, just a little bit of an overview. Alright, so first of all, when you're actually solving algorithms, alright, so algorithms are basically just pseudo code. Alright, so when you actually solve past papers, you will see that there are just multiple pseudo codes in which you have to find errors, or maybe you have to change something lines in them to make them perform something different. Alright, so basically what you have to do is that you have to read the question very carefully, obviously, and then you have to break down the problem into sub problems. Alright, so if you want to make an algorithm, right, so if the question is actually asking you to make an algorithm from scratch, it has just given you a question in simple English and it wants you to write down the pseudocode. First of all, you have to break down the problem into sub problems. Already you have to make sure that you are identifying what things you have to use, right? For example, if you want to count something, if you want to what type of loop you want to make, right? So you should try to make a list of all of the things that you need to solve the problem, right? So for example, if you want to know if you want to use a for loop, you want to use a while loop, you want to how many if statements you want to use, right? So make sure that you do this before you actually start writing your pseudocode. Then the next step will be to actually write down this code and combine them, and if you have enough time, you will try to test it. All right, you will make sure that it's performing what you actually wanted it to perform, right? And if you want to, and you will also get a few kinds of questions in which you have to amend an algorithm. All right, if that is the case, what you have to do is you have to basically understand what the algorithm should do and what it actually does. All right, and then you basically check the differences and you try to understand where the problem is actually occurring and what you actually have to change to make sure that you actually make the algorithm perform what you want it to. All right, so this is basically it for this chapter. Alright, so I hope that you like this video. Make sure to like my videos and subscribe to my channel, and I will be uploading more videos more often. Also make sure that you share these with your other friends who are studying the same subject. Alright, I'll see you later.